I'd like to introduce our keynote speaker, Professor Jon Gluyas of Durham Engineering Institute. John is a geoscientist with substantial experience in both industry and academia, and is a published author with a large number of research articles to his name, and he is deservedly President-designate of the Geological Society. I hope I've got that right, John.
Perfect. Ladies and gentlemen, I'm delighted to be here today. I do feel I'm a bit of an imposter. Despite having worked in the petroleum industry for some while, my interaction with corrosion has been somewhat limited. And before it comes out as outing me on TikTok or similar, I will reveal a little story. Back in 1990, I was responsible for production geology from the new Gyda field offshore Norway. Brilliant new platform, finely engineered, lots of new materials, including, I was told, some fairly novel alloys. And after a few months, or possibly even a few weeks, we had horrendous problems. The coolant, or the separator with its cooling fins in, was degrading rapidly. It turned out that Gyda was producing quite a lot of mercury vapor. And as a chemist by background, geochemist by background, folk came to me in Stavanger and said, "John, what can we do? How can we remove this mercury vapor?" To which I replied, "You seem to be doing a fairly good job." So, with that note of caution, let's begin. And also start the starter as well. There we go. You've heard something of my career. It can be summarized a little more simply. I spent 28 years getting carbon out of the ground, and the last 13 or so trying to shove it back in again, or at least not take it out. So let's start big. Let's start with the global population. It will come as no surprise to anyone to see a graph such as this. Perhaps by the end of this century, the global population will top out at around about 11 billion. Well, already, I'm not sure if it's happened yet, or it happens next week, India will become the most populous country in the world above China. And if you look at that in relation to the way in which energy has been used, let's just look at the more recent history, bringing us up to date in about 2020. And you can cross-plot, or what I've done is simply overlay that on the energy usage chart, which you see in the colours behind. It matches the population growth. Surprise, surprise. But the rate of energy growth, if you look at the shaded numbers and the bold numbers on the left-hand side, is about 1.6, 1.7 times population growth. So we're continuing to use ever more energy. Of course, that energy usage is not well distributed. And these rather contorted but rather delightful maps show where most is used. Again, no surprise, North America, Europe, and growing impact of China as well in terms of energy usage. And that is also reflected in terms of the amount of carbon dioxide which comes out of those systems, principally from burning coal, oil and gas. And again, you can see well, the relative poverty of some areas and, if you like, affluence and maybe over-affluence of others. But how much energy do we use? Each year, BP produce a really good statistical data set. It's not quite as good as it was, but it's still very good indeed. There are a number of things it's done of late which are really quite revealing. So the picture on the left shows 2019 divided into oil, coal, gas, and so on. We're trying to get to net zero by 2050, and so the block in the middle, the low block, is where we ought to be. If we think about an accelerated program from today, that's the middle chart on the middle of left. But what BP have also been doing of late is looking at current trajectories where we might be. And that's what they call the this new momentum. I don't think it's named after the Labour Party initiative at all. But projections of what might happen are pretty scary in terms of energy usage. And again, we know where that energy is used. Interestingly, the last time the UK appeared in the top 12 was a little over a decade ago. And some of that, of course, has been due to loss of industry, but also some of it's been due to some pretty dramatic changes in the way we energise the UK. I'm just going to have a look at a couple of charts to show the evolution through time. Here I've compared the big guns, China and the USA. That's a rather unfortunate term, isn't it? Anyway, that was accidental, I do promise you. But you can see how the energy usage in China has grown, the stasis in the USA. And again, if you look at Japan, a well-developed economy beginning to shrink, those are the palest blue dots. Russia's all over the place, and India is growing and growing. In terms of emissions from that process, again, I'm using some BP data. And again, what it shows is that the new momentum is not lowering as it needs to do to meet either net zero or an accelerated path towards net zero. For the UK part, we've actually done rather well. In the last couple of decades, we've substantially reduced our emissions. As of today, the UK emits about 1 million tonnes of carbon dioxide per day, around about 360 million tonnes per year. And some of that has been achieved by loss of industry, but quite a lot, as you will well know, has been done by the change in the way we generate electricity. Similarly, if you take Europe as a whole, and this time looking not at energy use, but CO2 emissions, Europe is coming down. India is growing, although still collectively Europe has much more than India. In terms of the consequences of fossil fuel use, they've been clear for some time, but let's just re-examine those very, very briefly. As a geologist, extinction, I know what Newton, that was a bit early, wasn't it? Darwin said, extinction is the common lot. But the rate of extinction today is massively more than we can observe from the admittedly incomplete fossil record. But we're also, because of the CO2 dissolving in the hydrosphere, we're leading to ocean acidification, and that leads to the difficulties of skeletal corals and things into growth. We all know very well about the impact that the change in, particularly CO2 content, but other greenhouse gases as well, is having on the atmosphere. And even the earth beneath our feet is not immune to this, with changes in elevation caused by mining, subsidence, and, of course, the dreaded induced seismicity. So how might we deliver a just energy transition? So first of all, a definition of net zero, which I guess most folk in the room are pretty much familiar with. We've got to eliminate or substitute for emissions. There's some controversy over offsetting emissions and the way it's accounted for. And the general consensus at the moment for things like bioenergy and CCS is that it's pretty dodgy as to whether or not it works. The overall piece we have to do is use less carbon fuel. And why is it so difficult? Why have we got hooked on fossil fuels? Well, it's very straightforward. The energy density in a lump of coal or a litre of gasoline is much greater than most of the other fuels that were available beforehand. It's much easier to get your products to market with a tuk-tuk and a small amount of gasoline than it is with a bag of carrots and the most willing of donkeys. And that's a statement to the second law of thermodynamics as much as anything else. Clearly, the super energy-rich systems of uranium and thorium, uranium, of course, has its own drawbacks, are not available to all. But folk who know much better than I do, or probably all of us in the room, some of the big hitting academic institutions say we can get there. It requires policy changes, it requires investment, and it requires commitment, not just from governments, but from people. Around about 2020-21, you can see that we're creeping towards 17% of renewables or sustainable energy systems globally. And folk are beginning to talk about a circular economy. Now, a lot of, I possibly wrongly assume, a lot of the things we'll hear during the course of today will be about materials and their resilience and reuse and so on. So they do provide an opportunity for a circular economy. Energy is a bit more difficult. To quote, is it Little or the other one? Once it's gone, it's gone. We are heading ultimately in a few billion years towards, we think, heat death of the universe. But we can make much better use of the energy that we do use. And I often quote the case here of a gas fire. A few years ago, the UK government said, tell you what, we know how to cut emissions. Everybody's going to have electric radiators. Gas will go. That was before the hydrogen unicorn came. And apart from the grid not being able to cope with that, if you look at the main way then, and still now that we produce electricity, then we burn gas. And when you burn gas, half of the calorific value of the gas goes straight up into the atmosphere. So in other words, you double the problem. You double your emissions by that banal statement. But anyway, never mind. We'll move on. So how do we displace fossil fuels? Without doubt, again to misquote a prime minister of about 20 years ago, insulate, insulate, insulate. We need to use less. We need to waste less. And then we need to start adding in all the things which we're beginning to see more prominently in the UK, whether it's offshore wind, photovoltaic systems. My own background, as you'll see in a minute, is a lot around geothermal and CCS and a few other bits and pieces. One of the neat tricks, though, of heat, which is a major problem, I should say in the UK at least, half of all the energy we use goes on heating, tiny, tiny bit on cooling. 77% of all that heat is produced by burning fossil fuels, and 33% of our emissions come from heat. And we waste an awful lot. We built our houses to vent carbon monoxide from burning coal. When warmed with a radiator, of course, that game changes. But with heat, we can keep reusing it. So you might use heat at 200 degrees centigrade for drying systems, say at a paint plant of a car factory. By the time it's degraded to 15 degrees, you can still use that heat for a fish farm. And so we can keep extracting ever more out of that process. But we will need to grow electricity supply around the globe. And again, using some of the BP data, where we're heading for is not nearly enough power generation. Bizarrely, and this, I first put most of this talk together in the strange days of last autumn. The UK government at that time said we're going to reduce emission, or we're going to produce more electricity by using more coal, oil and gas, hey? And we're going to install more low carbon capacity. It was statements without much support there. They went on to say we're going to further utilise North Sea reserves. We'll do another scientific review of shale gas extraction. We'll develop 4 new clusters for CCS, and we'll reduce gas consumption by 40%. My takes on that are in red. Yeah, you could do, the North Sea has lots of potential, and you could do it at very low emissions. And that includes use of some of the oil and gas. We've got the wrong kind of shale. I've been telling folk, well, not only I, many folk have been saying this to government for some time. This came and went. I don't think anybody's now doing that. 4 new CCS clusters, yes, very important indeed, but pretty trivial. 10, perhaps 10 megatons of CO2 out of that. There's 360, I think around about 120, a third of our emissions today could be captured by CCS. Don't tell you how we're going to reduce gas emissions. Yeah, great, well done guys. Clearly there's impact, whatever you do though, there's always going to be impact on the environment. We just have to minimise that impact and also look at what societally is acceptable. I've mentioned the second law of thermodynamics already, but I was born over the other side of the country in Lancashire, and we have a saying, you don't get out for nought, and that's basically you will get an impact of this. But we need to perhaps make the most of the green economy. So I'm going to just look at a couple of energy transition technologies, clearly the ones that I know a little bit about. So I will look at geothermal, we will look at hydrogen, a bit of CCS, and then some PACE. I'll leave it to others to look at those. Low-grade heat, which can be won anywhere around the globe. There can be no OPEC of geothermal energy. Sure, it's much hotter and faster with shallow depth in Iceland than it is in Azerbaijan, but nonetheless, there's heat beneath our feet. And a very rudimentary calculation done a couple of years ago would suggest if we abstracted heat in the UK and didn't put cold water down to get rewarmed, we've got about 100 years supply. And when you compare that with, I use it at today's rather profligate use of heat, if you compare that with oil, gas, or anything else, that's really rather good. But we can also capture and store heat in the subsurface. Let's capture it and store it in the subsurface. A big program at the moment, which is going on at Durham University called GEMS, is looking at how effective you could collect solar thermal and store that in abandoned mines. I'll come to abandoned mines in a minute. You know, on a day like this, we've got 2 solar thermal panels on our roof and a number of PV panels. The glycol in those panels will be at about 120 degrees centigrade, about just enough for my oldest son to shower. But the Earth can deliver, and it can deliver at low impact as well. One of the neat tricks we've developed over the last nearly decade now is that all the old mines that we used to use, 23,000 of them, 90+% coal, are where people live. Hang on a minute, no, it's the other way around. We, of course, live where we mine the coal. And those coal systems and the billions of tons of coal which has been produced leave voids in the rock which fills up with water. And in terms of matching both shallow mine systems and deeper geothermal sedimentary basins and granites, across the UK, we can match the occurrence of population density with availability of low-grade but still useful heat. In fact, the only major population centre which doesn't have access to this kind of heat is London. And there is a lot of hot air in London. No, there's a lot of hot air in, in the tube lines. Has someone, have I said? Right, okay. Seriously, and that is beginning to be realised and exploited. So how do these mine systems, or indeed any geothermal system, work? Groundwater, rainwater, percolates into the old workings and is heated by the earth. We're not going to cool the earth. I was on PM a few weeks ago and Evan Davis said, will we cool the earth? Well, not for 5 billion years or so. We should be all right. The sun will expand and fry the earth before it cools down. So that heating will heat the water, that can be extracted, and then the cooled water, after you've taken the heat out, but recirculated. We're not putting mucky mine water around folks' homes. What we're doing is extracting the heat with a heat exchanger, and it's that and fresh water which is used to heat places. Maybe needs upgrading with a heat pump, but then the impact of a heat pump is much, much less than direct power use. And it's pretty sophisticated. This is some of the heat modelling work, heat transfer work that some of my colleagues have done. Of course, there's a great deal of uncertainty here because we don't know the geometry of the mines, despite the old maps, too well. So not only mined water, but deep geothermal can control rescue as well. And although this is an old slide from last year, Eden came on stream this week. So Eden is the first new geothermal system in the UK for 40 years.
And the first one was an accident, not quite an accidental, but a serendipitous initiative from the accountants at Southampton Council, in that back in the 1970s we had an oil crisis. It took the UK government 10 years to drill any wells. They drilled some wells. By that time we were an oil producing nation and generally wanted to ditch the wells. But the accountant, why not the geologist? The accountant at Southampton saved the day. And even offshore, what I've got here is a diagram. Look on the right-hand side, looking at the Brent province in the North Sea. It's a little dated now. It's published in 2014. But what we did here is look at the co-produced water. And there are huge... The Ninian field produces, or produced at peak, 500,000 barrels of boiling water every day. That, despite it only being 110 degrees or thereabouts, can generate an awful lot of power. It could generate half the power requirement for the field, which means you wouldn't have to burn as much gas, raw gas, for those pumps to go in the ground. So that's just one of the things you can do for the offshore. So we've got a great opportunity, not just in the UK, but globally, to displace things like gas. Hydrogen, the unicorn. It gets talked about around the nation now. Currently, nearly all hydrogen is produced by reaction of water vapour with methane, which produces hydrogen and carbon dioxide. The carbon dioxide is released, and that nowadays gets called grey hydrogen. But you can see the demand growth, which is anticipated over the next few years or so. Hydrogen has in recent years become very colourful. You hear of green and blue and grey and even pink and most recently orange. But I'd like to introduce you to one you might not have heard much about, and that's gold hydrogen. And I called it that because, there's an old story here. A lot of these names were generated in the former Soviet Union. And they call the dirtiest, most polluting form of hydrogen black, and natural hydrogen, which is produced from the ground, white. And you just can't have bad black and good white hydrogen. So I tend to use the term gold. We've known for thousands of years that gases leak from the Earth's surface. Many of those are methane, but if you've heard of Chimera in Turkey, that's a natural hydrogen seep. And a few years ago, folk drilling for water in Mali accidentally drilled into a giant pure hydrogen field by accident. Is there another one to be found? Well, we don't know yet, but earlier this week, after much wrangling, Oxford and Durham universities formed a company to find out. So watch this space. The key bit there is that all the other... No, it's on the next slide. I don't need to. Sorry. At the moment, because you've got to manufacture hydrogen from methane, there is an additional cost. This is from KPMG a few years ago, and they forecast, I don't know on what basis, but they forecast this green, renewable hydrogen from electrolysis of water would eventually come down in price. But, you know, if we find gold hydrogen, it will undercut all of those because the finding price will be the same as methane. As for CCS, what a sorry story there's been in the UK. We've had 4 failures, sometimes at the first fence, sometimes, as in 2015, at the penultimate fence, where Osborne withdrew all funding just about the time that, despite it being a commitment, just about the time that the first programs were to go into production. But we have made progress largely on the wave created by the desire to deliver on COP26. And so as of now, there are 2 programs, one in the East Irish Sea, which will reuse some of the old Liverpool Bay fields to store CO2 in, and another offshore East Anglia into a truly enormous water-bearing structure now called Endurance, which sits on the south of that map amongst some of these gas fields, but somewhat shallower. And in both instances from the northwest of England, the HyNet project will be associated with
blue hydrogen, so that's creation of hydrogen with CO2 but removal of the CO2 for burial. Endurance has a much more eclectic mix from the northeast of England, from Teesside and from the Humber area of CO2 from a variety of industries, including power generation. Indeed, Drax claim, because they're shipping wood pellets from the USA, that they're going to be carbon negative. So what are energy transition requirements? Well, this is, I touched in some of the work I've done over the last few years, begun to touch on critical elements. And these are elements under threat for a supply not meeting demand. And the charts are issued, the USGS, US Geological Survey, issue this kind of chart every year. It varies, what's in the top 10, what's not. And there are other ways of looking at this same relationship between demand and cost, which are shown on the diagram on the right. Some of those we can reuse, others might be possible to up the production. So for example, we talked briefly about geothermal energy. Geothermal energy, many of those geothermal projects which are associated with granite, such as the Cornish projects, or even up our own Weardale, also have medium grade solutions of connate water containing lithium. And now with the improved production of lithium using direct lithium extraction rather than simply evaporation, we might be able to up our production of a number of different elements. But whatever we do, we've got to manage it within society. Whether it's earth, Eden, wind, the Hendy wind farm, or fire, bit of a stretch, the solar system, which is shown here for Hamilton. Folk tend not to like it if the inappropriate steps are taken in terms of information and availability of that information. So what we do is always ultimately control society by society, whether we're successful or not in these things. Will we be in 2050? Well, there are a couple of possibilities. Here just shows how much power generation will be required, and this is another piece from McKinsey. But basically, we need to multiply production of these low-impact systems by 2 or 3 or 5 times, improve bioenergy without destroying the impact with regard to access to crops and so on, food crops, and peak out. We're probably past peak coal now, despite the massive amounts which are still being mined. We are likely, it seems, on the downward trend. And this needs to be backed by investment. And these numbers clearly are eye-watering. These figures come from the International Energy Agency and similar. And you can see here that they're measured in billions and trillions. So money needs to go into these systems. So, in conclusion, we have to decarbonise. It's critical for planet health. As someone said, there's no planet B. If doing what we've always done is going to makes life very tough, we need to find alternatives to those energy-dense fuels. Some of the easy stuff has been done. Who here has noticed the switch from gas or coal-fired power stations to offshore wind? Nobody. It's been done without anybody, on land at least, recognising what's going on. Yes, we might see it in the news, but the switch on the wall is still the same. The next things will impact our individual lives. And it needs to be a just transition. It needs to be fair for everyone, and we need to do it now. And as the local lad come good, Sting said, one world is enough for all of us. Thank you. As my old boss in Caracas used to say, preguntas y comentarios.
do we take questions or?
Yes, if anyone would like to put questions to John, just please state your name and where you're working, which company you're with.
Could you wait for the microphone so it goes on to the recording, please?
Yes.
Was there a question?
I saw the news about the Eden project well, which is great, but I think even they admitted it was kind of a research project and not commercial in its development. So what are the main challenges that you see in deep geothermal?
Of the deep geothermal?
Yeah,
well,
to
it's
make it commercial.
both deep and shallow geothermal in the UK have proved very difficult indeed. There are a number of hurdles. For something like the deep geothermal, of course, the drilling cost for a geothermal well will be comparable to the drilling cost for an oil well. And although folk are talking about new technologies which vaporize rock and get you down to some ridiculous kind of temperatures, that's not quite there yet. And so that means it's a different business. Geothermal has the similar upfront cost to oil and gas, but a much longer and lower level payback time. With operating costs which are often very, very low indeed. So that's the initial exposure is very difficult. In the UK, at least, we don't have any regulation or legislation which is fit for purpose. So there have been some maverick drilling in the Lanchester Wines in Gateshead. They just drilled into the coal measures before anybody noticed. They missed the galleries first attempt, but that's a slightly different story. So the assessments are done on both Environment Agency and North Sea Transition Authority or Oil and Gas Authority rules. There is a perception of a number of developers I've spoken to say, oh, it's all very well and good, but we've never done geothermal. We'll just put gas in because we understand that. The events of the last few years have exposed the fragility, if you like, of supply in what are not global systems. But getting over all of this, I think if we've got a handful of projects which demonstrate through time small but positive commercial returns, that will start to influence piece. The other part we found, and this is particularly around the coal mine heat here, is that former mining communities with whom we've spoken, when you explain to them what you hope to do, the questions come back as, you mean we can share this resource amongst the village, amongst the town, and sort of re-anneal the society that was fractured in the post-Thatcher closure of the mines, to which the answer is yes. And then the next statement is, well, bring this on, we want this. So again, with the societal pull also helps. I suppose the tiny thing to finish on is, within the next 2 months, we will have a national geothermal innovation centre, which is designed to take the great research which is being done in the UK and get it into commercial realm. So that includes chasing policy, chasing regulation, looking at the way in which commercial exposure can be reduced, along with all the technical stuff. So watch this space.
Right. Anyone else would like to make? Yes. Could you state?
Yeah, Chris Kirby, I'm from Reblay today. You said that we hadn't noticed that the electricity was changing from its source, but there is now quite a lot of intermittent supply, you know, from wind and from solar. And when we tend to lose our wind, a lot of Europe loses their wind as well, and that's what we're using to sort of stiffen up the grid. As the amount of renewable sources come online, how do you think we're going to cope with maintaining grid stability?
Well, I'm not an electrical or a grid engineer. I think, first of all,
coming back to my first statement, we need to use, overall need to use less. I think we need to use heat far more to displace not just gas, but in some instances power as well. We might get there with the new generation of nuclear power stations, although heaven knows when Hinkley will actually come on stream. It's going to be tough. Overall, I think we will notice that. I don't have an answer. I should get a couple of my colleagues who might be better placed to answer that question than I can. It ain't easy though. Yeah. Have you got an answer? Have you got
well, there's a lot of companies now working on AI models to be able to redistribute power.
Yes.
So as we start going up more of electric vehicles, there are mobile storage units, yeah. But it's a huge problem, and it's one where AI is probably going to be required to keep the grid balanced. And there's going to need to be lots and lots of clever micro solutions all joined together.
Well, the other thing I should have said as well, I think a lot of the answers lie in community systems where there's a stake owned by, maybe a substantial stake owned by those who are using it. That would tend to improve performance as well as have get folk to be involved in how they live their lives. We tried a few years ago. I have a small spin-out company, and we had some students look at creating an app called Power My World, and they did some great work. And what they observed actually that you need to work on a system which linked. Basically, it was like landing a rocket. So you were always using energy. And you had to make decisions as to what you were going to put into that system. Was it going to be coal, nuclear, solar? And every time you did something, a little granny would appear. I don't know why they chose a granny, but a granny would appear and complain about it. So it was like trying to land a moon lander with decreasing energy and at the same time cope with interventions from outside. But what they noticed in doing that is that the unit people could relate to was on a family scale. So when you start to think about a town, unless you're thinking football or something which brings a lot of members of the town together, folk tend to think in much smaller units. And that's one of the ways in which you address this. It's the social piece. It never did come out as an app, but the Energy Institute has should come out in the next month, a top trumps on energy systems, which you might like to play.
Okay, we just have one last question.
To what extent does pumped storage and other facilities being developed in the UK, and what sort of projects are running with that? Because for me, the elements are missing. We've got the generation, but we don't have the storage. But the technology exists.
Storage is critical. Our entire storage system is atrocious. In terms of pump storage, we've got 1% maybe. There's a system in North Wales and in the Highlands of Scotland. I don't think we've got much more than that. Heat storage, I think, is one major solution which we're working on. There's a great, down the road in Durham, there's a small old, I think it was a fire station, and the car park of the fire station has it has loops beneath it. And on a day like this with black tarmac, it's collecting heat, that's stored underground, it's played back in the winter, and no salt is required for that particular area. So we can do that. In the Netherlands, they're doing that on a citywide scale. They were the first to exploit mine water heat. They found that by taking too much heat out, although they weren't cooling the whole earth, they were cooling that which was in connection with the mines. And what they now do is recharge during the summer months with industrial heat and solar heat as well, something we're following up with the GEMS project. Other storage possibilities which are being worked on include things like chemical heat pumps, where you can charge with very low-grade heat and then discharge with high-grade heat. And of course, people are beginning to use, as we heard from over here, at least conceptualize the use of the possibly, certainly at the moment, tens of thousands or millions of batteries which will be distributed around the country. Historically, though, we've relied upon
in having gas fields, your gas fields are also the storage sites. So we've historically had about 2 weeks gas storage, mostly in the Rough field offshore, which was decommissioned and strangely now is being recommissioned, whereas the French and the Germans each had 3 months of gas storage. We will see the development of gas storage systems for hydrogen, principally in salt. Aquifers will be more difficult because of bacteria can get in and change your hydrogen back to methane. Whether or not we developed compressed air storage, I think is still out to lunch because of the difficulty of capturing the heat during the compression phase and then reusing that for the expansion phase, as well as potential for, if in cave systems, of weakening the overburden by constant cycling. We're a long, long way behind on storage, and yes, it's a missing bit from here. Thank you.